In this video, we're going to look at one of the key fundamental skills we need to be able to do when we're working with polynomials and equations, and that's actually solving polynomials and equations. Now, when I say solving, what I mean is taking the polynomial, setting it equal to 0, and finding the solutions to this which give us the roots of the polynomial. Now remember, roots of the polynomial mean the points where the polynomial cuts the x-axis if we were to plot it. We're going to be looking to calculate this. Now, when we're doing this, there's one key fundamental rule in law we have to bear in mind and remember, and that's the factor theorem or remainder theorem. Now, what we say is if f of x, our polynomial, is divided by x minus h, then the remainder of this is f of h. And if f of h equals 0, i.e. the value we get when we substitute h into the original polynomial is equal to 0, we can then say that x minus h is a factor of this polynomial, and that x equals h is a root of the polynomial. So what we've found is points where the polynomial itself cuts the x-axis. When we've done this, we're actually able to write the function in this standard form here, where each part of this has a different meaning and a different part to the equation. So this one here is what we divided by. So this is the x minus h that we divided by here. This is what's called the divisor. This part here, q of x, that's what's called the quotient. So that is the solution that we get without the remainder added on when we divide through. And the f of h here, that's a remainder. Now, bear in mind that if this has no remainder, it's a root, so it'll then just be this format here. It'll have something added on at the end here if it's a remainder. Now, what we want to be able to do is prove something is a root of a function, prove something is a factor of a function, and then be able to calculate it and work it through so that we get all of the solutions. So let's look at how we would do that just now. So imagine the question simply states, is x minus 1 a factor of 2x cubed plus 5x squared minus 28x minus 15? Now, for this, what you need to bear in mind is that we've just said that f of h equals 0. If we get that, then it's a remainder. So if we don't, then it's not. Now in this case, it's when it's divided by x minus h. So here, for this example, we set h equal to 1. So what we want to find is f of 1. So if we substitute 1 into this and we get a value of 0 back, we know it's a factor. We know that we're then going to have no remainder, so it's a factor of it. So let's do that. So we do 2 times 1 cubed plus 5 times 1 squared, take away 28 times 1, take away 15. Well, 1 cubed is just 1, 1 squared is just 1, so it's 2 plus 5, take away 28, take away 15. So 2 plus 5 is 7, take away 28 is minus 21, take away 15 gives you negative 36. So that doesn't equal 0, so quite clearly we can then say that x minus 1 is not a factor. So it's not a factor of the original equation. So what we're not able to do then is we're not able to divide through and factorize this whole polynomial. At least not with x minus 1. We could if we found other factors of it, but we definitely couldn't do it where one of the brackets would be x minus 1. However, if we found it as a factor, what we're then able to do is we're actually able to then use synthetic division, divide the polynomial up, get it into a factorized format, and then use this to get our solutions for the equation. So let's look what happens when we do that. So imagine the question states, show x equals negative 5 is a root of the polynomial 2x cubed plus 7x squared minus 9x plus 30 equals 0, and hence solve the cubic. Well, the first thing we have to do is show that this is a root of there. And we do that the exact same way. What we want to focus on is the fact we know that f of h equals 0 for a root. And looking at what we're dividing by, x equals negative 5, we know that h equals negative 5. So substitute in. So we do f of negative 5 equals 2 times negative 5 cubed plus 7 times the negative 5 squared, take away 9 times negative 5 plus 30. So we substitute all these values in and work it through at this point. So calculating all the values through, we get 2 times, well, negative 5 cubed gives me negative 125, plus 7 times negative 5 squared gives me 25, minus 9 times negative 5, well, minus minus gives you a plus, so it then becomes plus 45, then plus the 30 on there at the end. So 2 times negative 125 gives me negative 250, 725 gives me 175, plus this here gives me plus 250, that equals 0. So from this, I'm able to say, fine, x equals negative 5 is a root. So it's definitely a root of the polynomial. So now it's a case of solving it. And at this point, this is where we use the synthetic division. So we set out our barricade with the value outside we're dividing by, and then we use the coefficients of our polynomial in here. So we have 2, 7, negative 9, and 30. Start by taking the 2 down. We then do 2 up and we multiply it by what's outside. We get negative 10. Go down the way, we do 7 plus negative 10, we get negative 3. Negative 3 goes up and again it gets multiplied by the value outside, gives me 15. Negative 9 plus 15 gives me 6. Again, multiply it up here, we get negative 30. The value down here then, 30 take away 30 gives me 0. This is what we should always get, remember, if it is a root. So this is almost like a double check, if you like. This is a double check to show me that I've got a root. But this also tells me now what the factorised form of 2x cubed plus 7x squared minus 9x plus 30 gives me. What I'm then able to say is, fine, I can write it as x plus 5 times the coefficients here of my squared polynomial. So 2x squared minus 3x plus 6, and that equals 0. Now to solve the rest of this, all I now have to do is factorise this at the end. So all I now need to do is factorise the 2x squared minus 3x plus 6. Once I've done that, I've got my 2 remaining brackets. I can then just read off my solutions. However, as much as we think about this, what we should do at this point is check that it works. Now, remember to check it, we use the discriminant, b squared minus 4ac, where we get the a, b, and c as the coefficients of our values here. So b squared minus 4ac gives me negative 3 squared, take away 4 times a, which is 2, times c, which is 6. Negative 3 squared is 9, 4 times 2 is 8, 6 8s are 48, so it's 9 take away 48. What that then gives me is negative 39. Now that is less than 0, and what this tells you, remember, think back to when we did the discriminant at National 5 and in the early stages of higher, because this is less than 0, I can't actually factorise this. So this part here doesn't actually give me any real solutions. When you get to advanced higher and we're looking at imaginary numbers, it comes into play, but I don't get any real solutions, so I'm not going to get any other roots. Only root I'm going to get is when x plus 5 equals 0, so x equals negative 5. That is the only solution and the only root I'm going to get to this equation that is a real number. If we were to break into the realm of imaginaries, we'd get 2 more. When we're solving cubics and when we're working these sorts of things through, we have to bear these steps in mind. We have to show, is it a root, is it not? Very quick check, f of h equals 0 for our roots. Once we've done that, it's then a case of factorising it. Use the synthetic division can make it a heck of a lot easier because we get our coefficients straight away. Once that's done, we then have to find the other roots, if they exist. Sometimes you'll get to a stage like this where you think, yep, 2 brackets, 2x and an x at the start, but lo and behold, your b squared minus 4ac tells you totally different. Check that every time and make sure of it.